You've all heard of Irvine Seller's shard and Renzo Piano's shard. One is a product of a developer's drive, the other an architect's creativity. They are two sides of the same coin, but whichever side you choose, both tend to gloss over the contribution of everybody else. We shouldn't really be surprised by this, because outside of the construction industry, very few people have any idea what the professions that we in this room represent actually do, and cannot even begin to imagine some of the ingenious ways in which we do it. Visitors to London who look at the shard from afar, and the people who enter it to work in its offices, dine in its restaurants, sleep in its hotel rooms, party in its apartments, and visit the viewing galleries at the top, will all be experiencing the piano or cellar version of the shard. And I'm not trying to say that this won't be a marvellous experience, just that the design and construction of the shard has had an unparalleled degree of innovation from the combination of engineers, architects and contractors, and that it's these contributions that make the experience marvellous. And because these innovations are easily and often missed, I call them the unsung heroes of the shard. So I'm going to tell you about some of the unsung engineering heroes that Arup have been instrumental in delivering at the shard, before speculating briefly about why the role of the engineer is often overlooked, and then giving you a brief taster of something that we've been working on to tackle this issue. The shard's geometry and appearance create a number of challenges of their own, but this is an unusual building in many other respects, and so to start with, I'm going to ditch the geometric representation of the building and start thinking about it a bit differently. This image is not based on geometry, but on the spread of people across the different floors of the building. You might think that this is a strange place to start a talk about engineering, but it's this distribution of people, with high concentrations of people at the middle and top of the building, that drives the fire strategy, which in turn has a massive effect on the design of the building services. The fire strategy takes advantage of the high-capacity shuttle lifts provided to the mid-level restaurants into the viewing gallery at the top of the tower to augment the protected escape stairs. This allows a significant proportion of the occupants of these levels to avoid the long and tiring evacuation by stair. There are 2 single-deck cars between the viewing galleries and the mid-levels with a capacity of 20 people per minute, and 4 double-deck lifts that travel between the mid-level and the ground, and these have a combined capacity of 80 people per minute. This means that you can move significant numbers of people around very quickly. As well as considering the concentrations of people, the fire strategy also has to consider the purpose for which they are in the building. As this building contains several different uses, consideration was given to the need for separate stairs serving the different types of accommodation. This would have had quite a detrimental impact on the internal layout and the lettable area, so instead, alternative protection measures were adopted, which allowed the stairs to be shared, and in combination with the use of the lifts for evacuation, this has meant that we've been able to keep the width and the number of stairs to a level that works with the building's tapering geometry. All of this has a profound impact on the design of the building services. The use of lifts during a potential fire means that the shafts must be pressurized to prevent the ingress of smoke, and pressurized refuges must also be provided to give people a safe place to wait as the lifts shuttle people to safety. The lift motors work hard and give off a lot of heat, and so the lift motor rooms need a cooling system that can keep running in the event of an emergency. And then there's the challenge of pumping large volumes of water from the bottom of the building to the top for the sprinklers and wet risers that the fire brigade will plug their hoses into. All of these systems must have a high level of resilience, so duty standby arrangements are used for the chillers, pumps, fans and other equipment, which have generator-backed power supplies so that they can be called upon at all times. These systems also need to know what to do depending on what happens in the building and where. The mixed uses and ever-changing geometrical arrangements mean that there are nearly 300 different scenarios to consider, with over 1,600 different reactions, all of which form the cause and effect matrices that act as the intelligence for the fire alarm and building management systems. A strong part of Renzo Piano's vision for the building was that it would be visited by the public, and as you can see, this has had far-reaching design consequences. I've already heard grumblings about the £25 entry price to the viewing galleries, but perhaps people would consider this as better value if they knew a little bit of what I've just told you. I've already said that the shard is more than just a pretty face, and that there's lots of substance to how the building works. But engineering also plays a massive part in the shard's light and transparent appearance. The facade is entirely constructed of glazed modules, and there are about 11,000 of these, which means that the building is subjected to high levels of solar gains. However, a triple skin system is used with a single pane on the outside, followed by a ventilated inner cavity housing a motorized solar control roller blind and a double glazed unit on the inside. An intelligent blind control system is used which tracks the position and intensity of the sun to deploy the blinds only when required. This traps the heat from the sun in the external cavity, which is then ventilated to the outside, minimizing the mechanical cooling loads to give an associated efficiency in plant and riser space, which is a key consideration in tall buildings where space is at such a premium. As a result of the deployable blind, the glazing itself does not need to perform a significant solar control function, and this allows it to be more transparent. It improves the daylight penetration and gives the building a clear light appearance, as well as reducing the amount of time when artificial lighting is required. The facade concepts were devised over 10 years ago, and given that the attitudes to energy were very different then, what's incredible is that the facade performance is still compliant with the recent 2010 revision of the building regulations. The 2006 edition merely required buildings to demonstrate that they did not overheat, which in an air-conditioned building like the Shard is easily achieved through the appropriate design of the air conditioning systems. But the 2010 edition placed limits on the amount of solar gain that's allowed to pass through the facade in the first place. The requirement is that the solar gains are less than those through a notional east-facing facade with 1 metre high glazing across its full width and glazing that allows just 68% of the incident solar radiation to pass through. Many people have assumed that this requirement would herald the end of the fully glazed facade, but the Shard's highly effective active facade shading system allows just 12% of the solar radiation to pass through when the blinds are down. People have been very quick to criticise the Shard for what's seen as an excessive use of glass, but I think it's a real triumph that despite being conceived in a different era, its performance exceeds the requirements of today. And possibly the greatest trick, especially given the high level of servicing required by the life safety and environmental systems, is making all of the plant effectively disappear. Flat roof space is the traditional home for building services plant, but in the Shard this option wasn't really available. There is some plant that absolutely must have access to flat roof space, such as the cooling towers that reject the heat from the chillers that cool the building. This is located on the small rectangular 18-floor extension to the east of the Shard, which has become affectionately known as the backpack. Because it's only 18 stories high, it's only really visible from the neighbouring streets. The roof of the backpack houses all of the equipment that needs access to outside air, and the equipment itself is located behind a louvered facade which allows air movement while shielding the equipment from view. The backpack roof has a limited area, which means that all the rest of the plant has to fit within the envelope of the building. This wouldn't necessarily represent a challenge, but the need to minimise the impact on lettable area, as well as working around building elements that are inside the building that would usually be on the roof, like the facade cleaning equipment, makes it all a little trickier. One of the drawbacks of internal plant is that it often results in a building looking something like this, with large areas of louvered dominating the facade, and this wouldn't be in keeping with the vision of continuous shards of glass. To avoid this, the spaces between the shards, which are called fractures, are used to get air in and out of the building, which means that you can't really see the louvers unless you know that they're there. This is just a taste of what I like to call the rock and a hard place engineering, where we're constantly trying to reconcile the demands of an iconic and highly visible external facade with the intense requirements of its internal workings. So, there are just 3 elements of engineering design that make the Shard very different to other tall buildings. But I have to wonder whether they will ever become widely known, because despite a rich history of innovation in building, it's really only a building's outer appearance that ever seems to attract widespread attention. A good example of this is St. Paul's Cathedral in London. St. Paul's has a unique role in shaping London's skyline, not just through its own appearance, but in the viewing corridors and height constraints it places on other buildings. I'd be willing to wager that most Londoners can identify St. Paul's, and that many would give sole credit to its architect, Christopher Wren. However, St. Paul's has its own unsung hero in that familiar dome. What you see from within the cathedral is a completely separate inner dome designed to remain in proportion with the internal architecture. This allows the outer dome and lantern to be larger and more impressive, and in between the two is a more steeply sloped brick structure, which supports the structurally weaker outer dome and heavy lantern on top. Although Wren generally gets the credit for St. Paul's in its entirety, there was no doubting the influence of his friend Robert Hooke, who was surveyor and engineer on a great many of Wren's buildings. In 1675, which was in the early stages of the building of St. Paul's, which would not be completed for another 35 years, Hooke finalised his theory on the ideal shape of masonry domes and arches, based on his understanding that the tension passing through a hanging chain is equivalent to the compression in a standing arch. It was this that was key to St. Paul's triple dome design, as well as representing a great step forward in our understanding of structures. The fact that such a significant engineering contribution to something that is so familiar can be overlooked does not bode well for the rest of us. As an aside, I also wanted to show you this picture that I came across, capturing one of Wren's regular inspections of progress on the dome. It reminds me of the Shard's use of the building maintenance units by the architects from Renzo Piano's office for their facade inspections. And if they weren't aware of this image at the time, then it's a shame, as knowing that they were following in Wren's footsteps might have been some consolation during the inspection of the 11,000 or so facade panels. As an engineer, I have to profess some concern with the lack of value placed on technical achievement. I suppose it should be apparent that the visual impact of architecture makes it much easier to engage with. But just because the engineering isn't obvious, it doesn't mean that it shouldn't be celebrated. I recently came across a Royal Academy of Engineering report on public attitudes to engineering, and I'd like to share one or two statements. Respondents recalled famous engineers such as Brunel and historical innovations in engineering such as the steam train, but were unable to name any modern-day famous engineers who had invented anything considered to be of similar importance. I think that we would all have to agree that quite a lot has happened in terms of engineering invention since then, so clearly there's an image problem. A lot of the responsibility for this perception of engineering probably rests with engineers themselves. Perhaps we underestimate the public's interest in engineering, or perhaps we're just not capable of articulating it in an interesting way. But either way, the right messages don't appear to be getting through. And why is it important that we communicate in technical terms? Well, there are various reasons that could form the subject of another talk in itself, but for me there are two main ones. The first is more benign and shares its aims with various initiatives to get young people more interested in science and engineering. Buildings are a very powerful tool because of their practical application of so many of the principles that are being taught in schools in maths, physics, design technology, and so on. More importantly, and perhaps less benign, is the need to avoid the politicization of science. By this, I mean that in the absence of strong messages from those who understand technology and science the best, the void is often filled by the less well-intentioned and the self-interested. Witness the controversy of climate change science that has muddied the water to the extent that the recent American presidential candidates would not even mention the words. On a more encouraging note, the Royal Academy report goes on to say that it was clear that even seemingly mundane things such as toilets, light bulbs and fresh water captivated the respondents and made them engage with engineering in a positive way. Mundane is something of a speciality. The Shard offers us a unique opportunity to start putting the record straight. Getting these messages across might be a challenge, but with the Shard we are guaranteed that people will at least listen, given the level of interest that there has been in the building. Stories about the Shard have been covered in a diverse range of publications and media outlets around the world. There's been a Fox, a Base Jumper, Urban Hackers, Royal Abseilers, to name but a few. As a building services engineer, it's been an unusual experience having people express an interest in what I do for a living, for once. So, we set ourselves the challenge of creating a short film with the ambitious aim of making building services interesting, without shirking from trying to explain the complexities at the same time. So we're now going to show you a short trailer which is about 5 minutes of the 30-minute video that we've put together, and we really hope you like it.
I joined Arup to work on a major project and this is what I got.
You know, there's not actually that many projects that we do that are run for as long and involve as many people. So, you know, this is the biggest I've done and it's probably the biggest I'll do for some time.
I've got to say, it's one of the greatest projects that I've worked on. It's a sort of once in a career project.
This is the story, not of the construction of the Shard, but of the dedicated team of engineers, both men and women, who behind the scenes provided the Shard with a safe, comfortable environment, bringing this building to life.
I'm standing right at the top of the Shard, and as you can see, we've provided a water supply, and this is almost 1,000 feet above ground level. So what journey did this water have to take to make it all the way up to this level? Water enters the building from the main in the street. It comes in and it fills these tanks. We then pump it with these 75 kilowatt domestic water pumps up to level 29, which is above the offices. From there, we store it and then we pump it again up to level 51. All the time on that journey, it supplies every part of the building with domestic water, until ultimately we store it in a dedicated tank and pump set at level 67, which is purely to get water right to the very top of the building to feed that tap, which is on level 87, almost 1,000 feet in the air. So why have we put all these pumps and tanks in this building? Why not pump it directly from the basement here all the way to the top of the Shard in one go? The answer is pressure. If a column of water stands in a single pipe from the top of this building to the bottom, due to the weight of the water, the pipe at the bottom must withstand a pressure of 300 tons per square metre. That's the equivalent of me trying to hold a 4x4 in the palm of my hand.
If someone smokes a cigarette in the Shard, this activates a fire alarm system. This activation is the cause. The effect is what happens to the different systems in the Shard due to the cause. For instance, the fractures that David talked about earlier, vents open to allow fresh air to enter the building. Another effect could be the lifts entering their evacuation mode.
In a normal building, you're advised not to use the lifts in an emergency. But as we've already seen, the Shard is not a normal building. The Shard's lifts are powered up and down through the use of large electrical motors, the biggest of which is about the size of a small family car. Now, in operation, these motors get warm and they need constant cooling to run without fault, but there's nothing strange about that. But remember, the Shard's lifts need to run in an emergency, so they need to run no matter what. Therefore, the cooling system that cools the lift motors must be extra resilient. For resilience, I've designed a completely standalone cooling system dedicated solely to the lifts and separate from the main system. The system is supplied by backup power and has two of every key piece of equipment, meaning if one fails, there's always another one to stand in standby to tap in and take over. The ability to operate in an emergency means that building occupants can be safely and quickly evacuated from the building, but it also means that firefighters can use the lifts.
Another way that I've helped to ensure the Shard works safely in an evacuation is in the lift and stair pressurisation system. In this system, large fans wider than I am tall are located at each of the equipment levels, and they blow outside air into the lift shaft and escape stairs. This means that the lifts and stairs are always under positive air pressure, so when you open a stair or lift door, air comes rushing out. This in turn means that smoke is unable to enter these spaces and the building occupants can safely escape using the lifts and stairs at any time.
So here we are deep in the basement of the Shard, in the boiler room. It's quite hot, it's quite noisy, and I'm stood in front of the 4 gas-fired boilers. The installed capacity of the boilers is equivalent of about 400 domestic boilers, typical of what you'd have in your house.
To give a few examples of the types of systems that we've designed, we have to ensure that enough fresh air is fed into the building to make it a pleasant environment. Just for the offices alone, there is enough air pumped in to fill a hot air balloon every 45 seconds. We designed the systems to both generate and circulate water to heat and cool the building. We've designed the electrical power systems, taking a cable from the street of 20,000 volts and made sure that it is possible to plug in a computer, a light or a kettle anywhere in the building.
One of the interesting things about London is that you can build buildings like this and still maintain those historical buildings. So it's this interesting juxtaposition of old buildings and new buildings, and I think London's quite unique in that sense. It makes you respect some of the people that are involved in buildings like St Paul's Cathedral, because they were built hundreds of years ago without the sort of technology that we have.
Well, I hope it's still here in 200 years' time, but I think there'll be I hope they're still impressed by what we've done, more than anything. There've been so many occasions on this project that we've gone further or done more than you would normally do, or innovated, and I hope that it sort of marks a line in the sand as a sort of, that's the new standard, and Buildings Forward take that on, and that becomes normal.
So now that we're coming to the end of the project, I'm starting to think a bit about what it'll be like looking back at its legacy in years to come. And it would be nice to think that it might have inspired a generation of engineers. Thank you for listening.
I thought it was very, very good. He presented very, very well. And I think it's a great idea of getting out there and kind of showing what engineers really do. I mean, the presentation itself, the visuals were all very good. And to be honest, I think it's something that's probably very long overdue, and it's a great idea to get out there. So I think we should do this on more projects.
It was very good, excellent in portraying a structure which has a great deal behind the scenes that you wouldn't otherwise understand and appreciate. And I thought it came across extremely well and really appreciated it.
I thought it was very interesting. Obviously, the Shard's been with us what seems like quite a few years now, and knowledge of it is fairly limited apart from how it looks architecturally.
Good morning. I thought the film was very informative. It was highlights the relationship between the architecture and the engineering. I enjoyed the graphics. I thought they were very good, and the presenter was excellent. So it was very informative.
It was absolutely fantastic. Really brought it to life. There is so much behind buildings that the average person doesn't know or even understand or even comprehend. So it was really great, and I'm really looking forward to seeing the next instalment of it. It's really good.